Hi guys, welcome back to Math with OG. In this section, we'll be looking at arranging fractions in ascending and descending order. So when you are given more than one fraction, how do you know which of them is bigger and how do you know which of them is smaller? With the invention of calculator, I believe that you all know that you can simply punch values on your calculator and use the decimal form of your answer to know which of them is bigger and which one is smaller. However, what if you are in an exam condition where you don't have access to calculators and you need to arrange fractions in either ascending order or descending order? How do you go about it? Now, there are basically two ways in which you can go about it without converting to decimal. One of the methods is simply arranging all the fractions to have the same numerator, and the other method is simply arranging the fractions to have equal denominator. Now, the one that is most common is making the fractions to have equal denominator, because we also use that during addition and subtraction of fractions. So the first case, whenever fractions have equal denominator, the higher the numerator, the bigger the number. So the number with the bigger numerator is actually the bigger number. So I have group of numbers here. Let's make the denominator to be 13. You have 2 over 13, you have 7 over 13, you have 6 over 13, you have 10 over 13. You are asked to arrange in ascending order. You just take a look at the numerator. Now before we proceed, ascending means from smallest to biggest and descending means from biggest to smallest. So when you ask to arrange from in ascending order, you simply take them from the smallest fraction to the biggest fraction, while when you ask to arrange in descending order, from the biggest fraction to the smallest fraction. Now in ascending order, this automatically becomes the smallest because when the denominators are the same, the smaller numerator is the smaller number. So you will have 2 over 13. Then the next should be 6 over 13. Next is 7 over 13. And lastly, you have 10 over 13. That is for equal denominator. Now, when you have equal numerator, the bigger the numerator, the smaller the number. So when the numerator is the same, the bigger the numerator, the smaller the number. Let's make use of the same numerator. You have 13 over 20, you have 13 over 17, you have 13 over 19, you have 13 over, let's say, 15. You are asked to arrange in ascending order. Arrange in ascending order. As long as the numerators are the same, as long as the numerator is the same, the one that has the biggest denominator is the smallest number. The one that has the biggest denominator is the smallest number. So if I'm to arrange in ascending order, it means from smallest to biggest. So this is the biggest denominator, so this automatically becomes the smaller number. The next is 13 over 19. The next is 13 over 17. And lastly, you have 13 over 15. So this is the biggest number because the numerator are the same. So this automatically becomes the biggest number. So this is arranging this guy in ascending order, and this is arranging this guy in ascending order. So now that we've known that, whenever you are given questions to arrange in ascending order, you either make the numerator the same or you make the denominator the same. I repeat, whenever you are given fraction, you either make the numerator the same or you make the denominator the same. So I'll use this as an example. We'll solve when the denominators are the same, which is the common one, and we also solve when the numerators are the same. Now to solve that, I will take you back to equivalent fractions, which we did in our previous video. Equivalent fractions, when you use the same number to multiply both numerator and denominator, the fractions automatically become equivalent. So you have 1 over 2, 5 over 7, 2 over 5, 2 over 3. So here we are going to apply one of the applications of LCM. Now we want to make sure that our denominator is the same. Our denominator is the same. So we look for that value. We look for a value and use that as the equal denominator. So if I look for the LCM of 2, 7, 5, and 3, I will get a value. Then I will change each of them to a fraction having that particular denominator. What do I mean? Let's continue solving. So you have 1 over 2, 5 over 7, 2 over 5, 2 over 3. The LCM of 2, 7, 5 and 3, 2, 3, 5 and 7. As you can see, there's nothing common between them, so it's just to multiply all through. But let's continue with find the LCM. 2 here, 1, 3, 5, 7. You have 3, 1, 1, 5, 7. You have 5, 1, 1, 1, 7. And you have 7, 1, 1, 1, 1. So the LCM is 2 times 3 times 5 times 7. 2 times 5 is 10. 3 times 7 is 21. So therefore, 21 times 10 should give us 210. So I will make all these guys to have a denominator of 210. I will make all these guys to have a denominator of 210. So if I put here, this is 210. So if 1 over 2 is to have a denominator of 210, you ask yourself, what did we use to multiply 2 that gave us 210? What did we use to multiply 2 that gave us 210? And that value should be 105. So if I multiply 2 by 105, it will give me 210. So if I have 1 over 2, multiply this 2 by 105 rather, it will give me what? 210. So for this fraction to be equivalent to this fraction, I must use that same 105 to multiply 1. So I'll multiply both numerator and denominator by 105. So this becomes 105 over 210. So I can boldly say that 1 over 2 is equal to 105 over 210. Similarly, for 5 over 7, you have 5 over 7. What will you use to multiply 7 that will give you 210? From here, I will have 2 times 3 is 6, 6 times 5 is what? 30. 7 times 30 will automatically give us 210. So since I'm multiplying 7 by 30 to give me 210, I should use that same 30 to multiply the numerator, and that will give me 150. Next guy, 2 over 5. What will I use to multiply 5 that will give me 210? This is 6 times 7, 42. It's simply 42. So I'll multiply it by 42, it will give me 210. Use that same 42 to multiply 2, and that will give me 84. Lastly, you have 2 over 3. 2 over 3. What will I use to multiply 3 that will give me 210? From what I can see on the board is simply 70. So if I multiply this denominator by 70, this will give me 210. I should use that same 70 to multiply the numerator, and this will give me 140. Now you can see that I have made 1 over 2, 5 over 7, 2 over 5 and 2 over 3 to have equal denominator. And what is the denominator? 210, 210, 210 and 210. So if that's the case, I can easily arrange these guys in ascending order, because when the denominators are the same, the bigger the numerator, the bigger the number. So where do I have the smallest denominator here? It's 84. So therefore 2 over 5 is the smallest number. What is the next smallest? 105. So therefore 1 over 2 is the next smallest number. Then what do I have again? 140. So the next should be 2 over 3. And lastly 150. This is what? 5 over 7. So this is arranging this guy in ascending order. 2 over 5, 1 over 2, 2 over 3 and 5 over 7. So that is the whole idea behind arranging in ascending order, or making fractions to have equal denominator. But in order not to pass through this stress, how do we go about it? By putting 210 here. I've looked for the LCM. The LCM is 210. How can I easily get 105, 150, 84 and 140 without going through this stress? I'll simply come like this. 2 into 210. How many times will 2 go into 210? The answer is 105. Use the 105 to multiply the numerator, and that will give us 105. So therefore, I can say 1 over 2 is represented with 105 over 210. The next guy, how many times will 7 go into 210? The answer is 30. 30 times 5 is 150. So I'll put a 150 here. How many times will 5 go into 210? The answer is 42. So we'll do 42 times 2, and that will give us 84. Lastly, how many times will 3 go into 210? The answer is 70. 70 times 2 will give us 140. So I've simply arranged these guys to have equal denominator. So therefore 1 over 2 is 115 over 210. 5 over 7 is 150 over 210. 2 over 5 is 84 over 210. Lastly, 2 over 3 is 140 over 210. Now that we've done that, then I can say the smallest number is 84. And what is 84 standing for? 2 over 5. The next is 115. What is it standing for? 1 over 2. Next is 140. What is it standing for? 2 over 3. And lastly, you have 150 standing for 5 over 7. So that is your answer in ascending order. In descending order, means from biggest to smallest, you start with 5 over 7, then 2 over 3, then 1 over 2, lastly 2 over 5. As easy as that. Now the next is to assume that they have equal numerator. So let's just do that, though you won't be applying that, just to gain the knowledge of using equal numerator. Now for equal numerator, you use exactly the same approach. Now you look for the LCM of the numerators. Now what is the LCM of the numerators? The LCM of 5, 2 and 2 is obviously 10. So you can do that on your own. We've learned how to find LCM. So the LCM of the numerator is 10 all over. Now we can use the same approach. What did I use to multiply 1 to give me 10? Is 10. So I can say 1 over 2. Since I used 10 to multiply 1, so I should also use 10 to multiply the denominator, and that will give me 20. So 1 over 2 is same thing as 10 over 20. Go to the next guy, 5 over 7. What will I use to multiply 5 that will give me 10? Is 2. So I should use that same 2 to multiply the denominator, and that will give me 10 over 14. Move on to the next guy. What will I use to multiply 2 to give me 10? Is simply what? 5. So we use that same 5 to multiply the denominator, and that will give us 25. Lastly, for 2 over 3, what will I use to multiply 2 to give me 10? 5. So I should use that same 5 to multiply the denominator, and that will give me 15. So we can say 1 over 2 is same thing as 10 over 20, equivalent fractions. 5 over 7 is same thing as 10 over 14, also equivalent. 2 over 5 is same thing as 10 over 25. And lastly, 2 over 3 is 10 over 15. If that's the case, remember, if the numerators are the same, the bigger the denominator, the smaller the number. The bigger the denominator, the smaller the number. So the biggest denominator here is 25. So therefore, 2 over 5 is the smallest number. The next is 20, 1 over 2 is the next. Next is 15, 2 over 3. And lastly, 14, 5 over 7. And if you observe, we got exactly the same answer when we use equal denominator. Now, how do we use this approach to get the answer? We've gotten the same numerator to be 10. So we are working with 10. So we say 1 into 10 is 10. 10 times 2 is 20. So that's the 20 we got here. So 1 over 2 is same thing as 10 over 20. 5 into 10 is 2. 2 times 7 is 14. You can see because we are working with numerator, we are using the numerator to divide. Now, 2 into 10 is 5. 5 times 5 is 25. And lastly, 2 into 10 is 5. 5 times 3 is 15. So 1 over 2 is 10 over 20. 5 over 7 is 10 over 14. 2 over 5 is 10 over 25. And 2 over 3 is 10 over 15. So you can see we got exactly the same answer. So this is how you approach answering question under arranging fractions in ascending order or in descending order. You arrange them to have equal denominator or you arrange them to have equal numerator. If you have access to your calculator, you can simply use your calculator to get your answer by converting them to decimals. Now in our next video, we'll be looking at operations in fraction. That means how do you add up fractions? How do you multiply fractions? How do you subtract fractions? And how do you divide fractions? That is what we'll be looking at in our next video. Thanks for watching this video. Kindly hit the like button if you found this video helpful. Also use the comment section to lay complaint or to ask questions. Then don't forget to subscribe if you are yet to subscribe. And lastly, please share to those who you think will need this video. Thanks for watching once more. See you guys in my next video.